Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. My name is Ahmad Shauki with student ID number 25 14 515 from Logistics Class 1A, Polytechnic of Energy and Mineral Gas. So, in this presentation, I'll be discussing the quality control in oil and gas products with a specific focus on a real-world case study, the Aviation Fuel Terminal, or AFT Juanda, located at Juanda International Airport in Surabaya. So this topic is directly relevant to what we observed and studied during our industry visit to AFT Juanda and Integrated Terminal Surabaya. So let's get started. Okay, to begin, let's talk about why this topic matters. So, efficient fuel, known as After or Jet A1, is one of the most critical commodities in the energy sector. Every commercial and military flight depends on it. Any disruption in its quality or supply chain can lead to serious consequences. Flight delays, safety hazard, and significant economic losses. So AFT Jonda is managed by PT Pertamina Patraniaga. So this is the frontline facility that's responsible for receiving, storing, and also distributing the Jet A1 to airlines operating at Jonda International Airport. It sits, it sits at the very end of a long supply chain, and it is here where the quality must be guaranteed before the fuel ever reaches an aircraft. This is why quality control is not optional in this industry. It is absolutely non-negotiable. International aviation regulations demand rigorous multi-layer quality checks at every stage of the process. So this presentation has five main objectives. First, to understand the concept of the multi-layer quality control framework applied in oil and gas products distribution. And second, to identify the specific key C or quality control processes carried out at AFC Juanda from pipeline receiving through tank storage, pre-delivery, and all the way to aircraft refueling. And third, to examine how FT Juanda complies with international standards, including ASTM D1655, DIF Stan 91.091, and AATA fuel quality requirements. And fourth, to analyze the root causes of common quality defects and operational risk in aviation fuel logistics. And fifth, to propose the concrete data-driven recommendation that can improve quality control efficiency, safety, and traceability at AFT Juanda. And here also, this one, the structure of this presentation. So we will begin with an introduction to quality control in the oil and gas context, followed by an overview of the AFD Juanda supply chain. Then we will look at the regulatory standards that govern Jet A1 quality. And from there, we will go deeper into the multi-layer key C checkpoints applied at AFD Juanda, covering both of the upstream side, the pipelines, receiving and storage, and the downstream side, pre-delivery and aircraft refueling. And we will then examine common quality defects on their associated risks, followed by our key challenge and recommendations. And finally, we will wrap up with our conclusions at the end. So, let's begin. Okay, so let's move to the section 1, the introduction to quality control in oil and gas. You can see that a picture of me in AFC Juanda. during a industrial visit. So, what exactly is quality control in the oil and gas industry? So, quality control, or QC, refers to the systematic set of processes used to ensure that the product meets the specified quality standards before it is delivered or used. So, in oil and gas, this means the testing and verifying the physical and chemical properties of the product at every critical point along the supply chain. And at AFT Juanda, this is taken very seriously. So KC is not just a single check. It's applied at five distinct points. When fuel arrives through the pipeline from integrated terminal Surabaya during a daily tank monitoring after severe weather events like heavy rain, before each truck or dispenser is loaded, and again right before the fuel is pumped into an aircraft. And to give you a sense of the scale, so after travels through a dedicated underground pipeline of approximately 30 kilometers from integrated terminal Surabaya to AFT Juanda. So the fuel must meet two major international standards. First, ASTM D1655 and DEFSTAN 91-091 before it is considered safe to use. So this multi-checkpoint approach is what makes aviation fuel is one of the most carefully controlled petroleum products in the world. Now let's look at the full supply chain behind the after that reaches AFT Juanda. So it begins at the refinery level. The Pertamina refinery unit 4 in Cilacap, Central Java, and the refinery unit 5 in Balikpapan, East Kalimantan, produce the Jet A1 fuel that meets the STM D1655 specifications. And from there, the fuel is transported by oil tanker through the sea, arriving at the Tanjung Perak port in Surabaya. It then enters the integrated terminal Surabaya or IT Surabaya, a major fuel storage hub that covering 14 to 17 hectares at Tanjung Perak. And this is where the fuel is stored before being pushed forward from IT Surabaya. And the after is pumped through a dedicated underground pipeline approximately 30 kilometers long, just like I said before, directly to AFT Juanda. And at AFT Juanda, which is a focus of this presentation, the fuel is received, stored, and quality checked and distributed to aircraft through two methods, the refueler trucks or hydrant dispensers. And finally, the fuel reaches the aircraft or the end users, the customer, we can say, which are the domestic and international airlines operating at Juanda International Airport. And every stage of this chain involves quality verification, but it is at the AFT Juanda where the most critical final checks take place. Okay, so next, before we look at the actual quality control process, let's understand the standards that govern them. So the primary standard is ASTM D1655, published by the ASTM International. This is the global standard specification for aviation turbine fuels. It defines the specification, the acceptable ranges for key properties of Jet A1. First, the density. The density must be between 775 and 840 kilograms per cubic meter. And the flash point must be at least 38 degrees Celsius. The freezing point must not exceed negative 47 degrees Celsius. And the water content must stay below 30 parts per million or ppm, and the fuel must appear clear and bright. And the second standard is DEF 1091 and 091, published by the UK Ministry of Defence. This standard sets JSA1 quality parameters for both defense and civil applications. FT Juanda applies both ASTM and DEF stand to ensure dual certification compliance. And the third is IATA or IATA Airport Handling Manual or AHM. This describes how often fuel must be sampled and how it must be handled and what chain of custody documentation is required at every stage from the storage tank all the way to aircraft. And finally, the ISO or ISO 9001 provides the quality management framework, the documented procedures, corrective action protocols, audit trails, and continuous improvement processes that underpin Pertamina Patronaga entire key operation. These four standards working together form the backbone of quality assurance at AFT Juanda. And okay, so let's get into the heart of this presentation. The five quality control checkpoints applied at AFT Juanda. And so checkpoint one at pipeline receipt. Every time a new batch of after arrives through a pipeline from IT Surabaya, it is tested for density, flash point, visual appearance, and water content. This happens before the fuel is even allowed into the storage tanks. And checkpoint 2 is the tank storage. Daily check. Every morning, the operators collect samples from the bottom of each tank. They check the density, color, and clarity, and drain any accumulated water. So, and this is a routine but critical step to prevent the sedimented and water buildup. And checkpoint 3 is a post-weather check. After a heavy rainfall or storms, an additional inspection is a mandatory. Water that seep, can seep into tanks or pipelines and contaminate the fuel. Operators check water content, particle contamination, and conduct a full visual inspection. And checkpoint 4, the pre-delivery check at the filling shed. Before any refueler truck or hydrant dispenser is loaded with fuel, um, not for hydrant dispenser because it has no tank. It is some kind of pump. So let's continue. The filter and separator are checked. Water is drained and a millipore differential pressure test is performed to verify the filter integrity. And checkpoint 5, pre-refueling on the apron, right before the fuel is pumped into any aircraft. So the operator verifies density one more time, takes a drip sample, and confirms that the fuel is clear and bright. Only then does refueling begin. So these five opportunities to catch a problem before it becomes a safety incident. And let's look more closely at how the quality control works in receiving and storage stages. So on the receiving side, the process begins with coordination between IT Surabaya and IT Juanda operations. So the team to from IFT Juanda confirm the delivery schedule. schedule. When fuel arrives at the manifold, operators monitor pressure and flow rate in a real time, and the manifold is equipped with a strainer to catch any large particles. A calibrated flow meter measures the exact volume received. This is the custody transfer measurement, which is the official record of how much fuel changed hands between IT Surabaya and AFT Juanda. The fuel then passes through a filter separator and removes residual water and fine particles before entering the storage tank. And the entire tank filling process is monitored using an automatic tank gauge. So operators always know the exact level without needing to climb the tank. On the storage side, tanks are either fixed roof or floating roof type, made of carbon steel with internal anti-corrosion coatings. Every tank is equipped with grounding cables and lightning protection to prevent a static electricity buildup, a critical safety measure given the flammability of jet fuel. So the daily bottom draining and water sampling are carried out, and strict FIFO first out, first in, first out. The rotation ensures older fuel is always used before the newer arrivals. The facility also has a comprehensive fire protection system including water sprinklers, and high-capacity fire pumps. And tank inspection and cleaning are scheduled in rotation, so not all tanks go offline at the same time, maintaining continuous storage capacity. Well, now let's move to the downstream or the end of the process. So pre-delivery and the actual refueling of aircraft. IFT Juanda used two methods to deliver fuel to aircraft. First, the refuel truck. This is specialized fuel tanker vehicle equipped with its own storage compartment over the tank, the pump, filter separator, and digital flow meter. Before loading, the operator drains any water from the truck's compartment, checks the density, and inspects the hoses and nozzles. Fuel is loaded through a bottom loading system with the volume recorded by the flow meter, and the truck then drives to the aircraft's parking position on the apron. Before pumping begins, a grounding cable is connected to the aircraft to eliminate any risk of static discharge or electricity. And after refueling, the operator issues a fueling receipt to the airline representative as an official record of transaction. The second method is hydrant dispenser. This system uses an underground pipeline network installed beneath the apron. It connects directly to AFT Juanda storage tanks. A hydrant dispenser is a vehicle, a lighter unit with a pump, filter, and flow meter, connects to a hydrant pit in the ground near the aircraft. The operator performs the same pre-delivery quality control checks, filter drain, water drain, and appearance check, and then connects to the aircraft for pressure revealing directly into its wing tanks again, and the fueling receipt is issued at the completion. And to remind you of what the fuel must be when it reaches the aircraft, density between 775 and 840 kilograms per cubic meter, flash point at least 38 degrees Celsius, freezing point no higher than negative 47 degrees, water content below 30 ppm, and the fuel must be very clear and bright. If any of these criteria are not met, the fuel doesn't go to the aircraft. Period. Okay, now so let's look at what can go wrong and what AFT does about it. The first risk is pipeline single source failure. Because AFT Rwanda depends entirely on one pipeline from IT Surabaya, any damage or maintenance shutdown on that pipeline means zero fuel supply. This is rated high risk. The mitigation is to develop the contingency plan using road tanker trucks as an emergency backup supply mode. And the second risk is BS and W. That's a basic sediment and water or water contamination in the storage tanks is rather critical because contaminated fuel can cause severe engine damage And the solution is a daily bottom draining combined with a portable real-time analyzers that can detect water content on the spot. And the third is off-spec density or flashpoint. So the fuel that doesn't meet the specification. Also critical, as this is a direct flight safety risk. AFT Juanda addresses this with a strict hold and release protocol. No fuel is distributed until laboratory results confirm it meets spec. And fourth, the regular trafficking during peak hours, typically mornings and evening when a flight activity is highest. It is rated medium risk but has a direct impact on the airline on-time performance. The recommended solution is a digital scheduling system link in airline flight timetables, which is already applied in AFT Juanda. And fifth, hydrant pipe leaks under the apron. Older five underground pipes can corrode and develop leaks, creating both a loss and fire risk. It is high risk and mitigated through a scheduled NDT, non-destructive testing, inspections, and proactive pipe displacement. And six, the human error risk in manual quality control. When the sampling and recording are done by hand, there's always a chance of error or inconsistency between operators. This is high risk, and the solution is to digitalize the entire QC recording process using a tablet or mobile application integrated with a company quality management system. The next challenges and recommendation on Octogenous. Building on those risks that I've said before, let's look at the four main challenges and our specific recommendation. Challenge 1. If Tujuan has a sole pipeline dependency, there's no backup route from IT Surabaya. So if that pipeline goes down, operations stop. Our recommendation is to build a secondary pipe or at the minimum pre-arrange emergency fleet of a road tanker truck. It can be mobilized immediately. And challenge 2. Manual quality control sampling is prone to human error and variability between operators, or our recommendation is to deploy portable real-time quality analyzer on site and devices that can instantly measure the density, water content, and flash point without waiting for laboratory results. And challenge 3, slow laboratory turnaround times delay high distribution decisions, which is the problem especially during high demand periods. Our recommendation is to digitalize all the QC records through a tablet or mobile app integrated with the company quality management system. This creates the real-time data, instant traceability, and easier audit compliance. And challenge 4 is the truck bottlenecks during a peak hours creates keys the filling shed that can case that into flight delays. Our recommendation is a digital scheduling system, one that is linked to the airline actual flight, so that truck loading slots are pre-allocated, then bottlenecks are eliminated before they happen. And each of these recommendations is practically directly applicable and directly linked to the real condition we observe at FT. So these recommendations actually has been applied by the AFC Juanda because as we know they are a professional and you can tell that they're the best at handling this aviation field. And now we arrive to the conclusion. So to conclude, let me summarize the five key takeaways from this presentation. So first, the quality control at AFT Juanda is a comprehensive multi-layer system spanning from the moment fuel arrives through a pipeline all the way to the refueling nozzle touching the aircraft. So it's fully aligned with the ISTM D1655 and DEFSTAN 91091. And second, the 30-kilometer dedicated pipeline from IT Surabaya is an efficient and contamination resistant supply method. but it creates a single point of failure that demands a serious, well-prepared contingency plan. And the third, the five quality control checkpoints. The pipeline receipt, daily tank checks, post-weather inspection, pre-delivery, and pre-revealing represent a global best practice in aviation fuel safety management. And the fourth, the technology is the most powerful lever available to improve the quality control quality. Portable analyzers, scale, the pipelines monitoring, and the digital key recording system all work together to reduce the human error and speed up critical quality decisions. And the fifth, the fundamentals still matter: continuous operator training, strict first in, first out stock discipline, and schedule and DT pipelines. Inspections are the everyday practices that sustain QC excellence at AST Juanda over the long term. So this is the end of the presentation. I'm Ahmad Shauki from Logistic Class 1A. Thank you for watching. Thank you for attention. I hope this presentation has provided a clear and useful picture of quality control in oil and gas through the lens of real-world class aviation fuel facility. That's all from me. Thank you. Wassalamualaikum warahmatullahi wabarakatuh. Bye.